Welcome to Homework Lib.
We're given a couple of questions, but unfortunately we're not given the previous parts. So in order to answer both of these, we're going to require both of the previous sections. So over here, I'm going to assume, since this is going to be a decomposition, that this will be a first order process, which is most likely going to be the case, in which we're going to have AB that is going to decompose into A plus B. So in this first order process, what we know is that the concentration of AB as a function of time is going to be equal to my initial concentration times the exponential of minus k times t. So, in this case, if we want to know how long will it take for the concentration of AB to decrease from 0.52 to 0.15, what we would get is that the value of 0.52 would be my initial concentration and 0.15 would be my final concentration. Let's write it down as C final or CT, just to exemplify that this is a concentration as a function of time. So what you would require to do would be rearranging this equation as Ct over C0 is equal to the exponential of minus k times t, solving for t, taking the logarithm, and this would be a logarithm of Ct over C0 is equal to minus k over t. Thus, the value for time that you would solve would be equal to minus logarithm Ct over C0 divided by k. The value for k probably is going to be included in one of the previous questions, and this would become logarithm of c final 0.15 over c initial 0.52 over the value for k. And this would be your answer for time in this section. Now we're given that if on part E, if the initial concentration is 0.26 and the reaction mixture initially contains no products, what are the concentrations of A and B after 80 seconds? So what you're going to do in this case for part E is calculate the concentration of the species AB at that time, 80 seconds. And since the chemical reaction is going to have a one-to-one relationship, if we write down an ice table, then the amount of change is going to be given plus as follows: C0 minus x, x, and x. So the difference that we're going to have on the concentration of AB will be the concentration of A and B after 80 seconds. Okay? So what you're going to do is calculate C of AB at 80 seconds, which is going to be equal to 0.26 times the exponential of minus k times 80 seconds. And the value for x would be equal to my initial concentration minus the concentration at 80 seconds. Thus would be 0.26 minus 0.26 times the exponential of minus k times 80 seconds. And that is how you're going to be able to calculate the concentration of A and the concentration of B. Both of them are going to be the same, remember. And with that, it would be all. Thank you very much and have a good one. Just remember that you're going to need the value for the rate constant of this process in order to solve these two parts.